when you have an expression like this, it's implied that x can't be -1 because you can, just by plugging in a -1, you'll see you're dividing by 0. And then if we simplify that, it simplifies to x plus 1, and so we've lost that, that part of it that implies that x can't equal -1, so we actually have to say that it doesn't equal -1 in order for these two expressions to be equivalent. These two functions. These two functions are not the same function at x equals -1 because this function isn't defined for x equals -1, so we have to put the similar restriction on there. Okay, so if we have, yeah.
So the following example, you didn't exactly give that example from correct.
This is as far as I went.
I'm correct, yes.
Okay, Riley, you all set? I'll be posting the notes if you don't get everything. Okay, so let's say we have an expression here that we're trying to simplify, and so what we'll do is we factor it and factor it some more. You see how that x squared minus 16 can factor, and so now we have like factors here. This x minus 4, they're the same factor. And so that equals 1, and it equals 1 everywhere except where x equals 4. Okay, so when I simplify that and drop that x minus 4 out, I have to say x does not equal 4. So all of these, starting from here, these three, are all equivalent expressions. This one is equivalent only if we call out that x does not equal 4. Now, of course, just like in the original one, x can't equal -2, but that's an implied domain restriction that remains. Okay, it's obvious from this that it can't be -2. But this one, it works if you put in a 4, but in that case it isn't the same. It doesn't give you the same value as the original expression, and so you want to declare that. Yes, you had a question.
So I understand how that works. I'm just wondering, how did you choose 4?
Well, because I looked at what I eliminated. Okay, I canceled out the x minus 4, and so I can only cancel that out when x does not equal 4, and so that's where I got that from. Is when I'm canceling out terms, what in that term that I've canceled makes that 0 over 0. Okay, because then it's not the equivalent expression.
And you don't put negative numbers?
Well, you can put, if it turns out to be a negative number, then you put negative numbers.
Oh, because negative and negative make it positive. Is that why you put positive 4?
No, I put positive 4 because 4 minus 4 equals 0. So if I expand it like this, and I'm looking at this expression up here, this first one that I've factored, x can't equal 4 and it can't equal -2, otherwise we have division by 0. Okay, so on this next one, after I factored that x squared minus 16, I noticed that I can cancel out my x minus 4s, and so here, canceling only works when I'm not canceling 0. I can't cancel a 0 over 0, and that's what I would be doing if x equals 4.
I thought you were just crossing out the negative 4s and putting it on the outside, but now it's...
Well, it's a way to look at it. You know, it's the additive inverse of -4 is what it is. But yeah, you ask yourself the question, since I've canceled out this term, when does that term equal 0? And then you put when it equals 0. Yes?
Would you mark it wrong if we also put x equals -2?
Certainly not. Okay, because that's true. Okay, there's nothing that's wrong about that. It's just not necessary.
So wait. So how do you determine if, you know, 4 the x doesn't equal 4 again? Like you just...
Well, I'm canceling terms. You see, when I go from here to there, I've canceled out the -4 over -4.
Oh, okay.
And the reason why you cancel that is because for every value of x, that equals 1, right? -4 over -4. Like if x equals 10, you got 6 over 6. But when I have x equals 4, then I have 0 over 0, and that doesn't work. Okay, so when I'm canceling out a factor, I have to make sure that that factor can't be 0, and so that's
All right,
x minus 4 is negative, we'll make it 4.
Once it's 0, it deals off. Got it.
Okay, so here's one for you to try, and so you'll have to factor and then keep track of what you're going to cancel. So
Is that x squared on the denominator?
the numerator factors by 2x minus 1 times x minus 4. The denominator factors as x minus 4 times x plus 3 and make that negative. Okay, so then when we cancel out the x minus 4, we have to make sure that the x minus 4 is listed as a domain restriction. Yes?
Negative that's at the front, like just.
That negative in the
just
front
ignore it, right?
comes from the negative down here.
Yeah, but there's. Yeah, but you don't use it. You just like ignore it, right?
Well, it's not ignored, it's part of the solution, right?
Wait, do I need to put it like I've put mine in like that?
Yeah, that's fine.
I can just do that.
Yeah, you can do that. Her question was, if this was in parentheses with the negative in front of it, that would have been fine too, okay? In other words, if you just write this without the x minus 4 in there and keep that, that negative down there, that would have been okay. Yes?
Something more, if you're trying to graph it, are you allowed to have a negative x in your parentheses or not?
You can.
Because how I did it is like I put negative x minus 3, then I times it with x minus 4. So I'm wondering if that's okay to move my factors to negative x and negative 3 in parentheses.
Yeah, so in other words, you came out with this then?
Yeah.
Yeah, that's fine. That's the same thing. And sometimes, another way to write this is we can write it like this as well. Okay, recognize that I can take that -1 and distribute it to the numerator, and then just change the order, and we'll have, you know, the negative side in between. So you'll see this format frequently too, even though, you know, we've talked about how you properly write a polynomial with the leading term first. Yes?
So when I wrote the answer, I did 2x plus 1 over negative, and then parentheses x minus 3.
It's 2x minus 1? You said plus 1.
Oh. Okay, well, it's minus 1. Well, my question was, can I put the negative outside the parentheses of x plus 3?
Sure.
Is that correct?
Yeah, that's what I, yes.
You know that answer here, is that acceptable if I put down a test?
Yeah, oh yeah, yeah, all these things are equivalent, okay? So this one, this one, this one, so long as they all have the domain restriction here. Okay, so let me take you through a couple more examples here. Let's say we have something with a y in it now, okay? So now we have two variables. So you should be able to factor these. And so the way we factor it is you first take out the largest monomial factor from both the numerator and the denominator, and then factor what's inside the parentheses. And so we get 2 times x minus y times x plus 2y over 5x, x minus y, and x plus y. Okay, so now this leads us with a little bit of a different situation, because if you look at what would cause the domain, what domain restrictions are implied here is that x can't be 0. Okay, that's straightforward enough. Now this one suggests that x and y can't be equal. And this one suggests that x can't be negative y. Okay, but we're going to cancel out this term here, this x minus y. And so we've ended up with this expression, and so we still have the implied domain restrictions of x does not equal negative y and x does not equal 0, but we have to write that since x minus y can't be 0, we can write it like this, or we can write it like this. Both of them say the same thing, okay, where x can't be y, because if x and y are equal, then we have division by 0, and of course that can't happen then. And so that's the way I would write the question. I certainly wouldn't count it wrong if you wrote x minus y does not equal 0. Although traditionally you put them on opposite sides.
Is our homework for this on web work?
It will be, yes.
So how do we put that into time?
I'd have to look at the questions first. I'm basically taking the WebWorks set that I made last semester, and I'm going to modify it, but I haven't read through it yet.
Okay.
So it'll be posted before, well, as usual, it'll be posted around mid-afternoon today. Okay, so here's one for you to try. I want you to simplify this. And actually, just in the interest of time, I'll show you the solution to the second one, but I'd like you just to do the first one, and then when we get that, I'll show you the second one. Okay, how does that first one, how does the numerator of that factor?
Y minus 8x, y plus 8x.
Right, so you got the difference between two perfect squares. And then what about the denominator of that? How does that factor?
You can factor out the 3.
Factor out the 3 and you get,
15 parentheses y plus 8x.
okay, great. So it factors out like this. And so then what we have is the y plus 8x is what gets canceled, and so we just have the y minus 8x in the numerator, and we just have the 15 in the denominator. And so what we have to say here is that this expression, this y plus 8x, should not equal 0. So if we make that equal to 0, we'll find that y equals negative 8x, and you put the does not equal sign because you're making the restriction. Okay, everybody follow that? Hopefully you got that. All right, so this next one, let me just walk you through it. Basically what we want to do is first factor it, and if we look at kind of the initial factoring here, I guess this is going all the way to the solution, but if you look at the initial factoring, you take out this 3, and then recognizing this as being a perfect square, right? This is m plus 2n all squared, because the first and the last terms are both perfect squares, and so you take those m times 2n, multiply those together, multiply it by 2, and you get 4mn. So that's the way that factors, by recognizing the special form. It's a little harder to see than if you had pure numbers, but it's still there. And so then we look at the top and we think, okay, well that can be factored again because we have the difference between perfect squares. And so here's our factored forms. And then notice that we have the m plus 2n in common. Now, I have 2 of them in the denominator here, and only one of them cancels out. So the domain restriction is implied here that m does not equal 2n. So whether you put that or not, you're okay. You don't, strictly speaking, you don't need it because that domain restriction didn't change, or it's still implied that m can't be 2n. Okay? M can't be negative 2n. Okay, so let's go on here. Now we want to talk about multiplying and dividing rational expressions. And where this is going to end up, ultimately when we're dividing rational expressions, we're learning how to divide polynomials as well. Okay, so let's look at multiplying and dividing. Multiplying actually turns out that you already know how to do this based on what we've just done in simplifying polynomial expressions. Okay, so let's look at the theory behind this. If we have u, v, w, and z, and let that represent real numbers, variables, or algebraic expressions. So anything that we've been dealing with so far, if we take the ratio of 2 of those and multiply it by another ratio, what we get there is that we can do the multiplication, multiply the numerators, multiply the denominators. So essentially just take out the multiplication sign here, draw your division line all the way through it, and you have uw over vz. And of course, v and z can't be 0. They couldn't be in the original problem, they can't be here. Okay, so in one example, if we have 6x over x minus 2 times x minus 3 over x squared, the thing that you have to add here to keep it all straight is make sure you're using parentheses to your advantage. Okay, so I'm going to write this as just the product of those two. Now I can notice that I have an x in the numerator and an x squared in the denominator, so one of those x's can go, so it's going to end up to be just 6x, or 6 times x minus 3 over x times x minus 2. Now we canceled out an x, but we still have an x in the denominator, so we don't have to worry about our domain restriction. So just like we did before when we were simplifying, when we're simplifying here, we have to note our domain restrictions. This one has the implied domain restriction, so we don't really need it. Okay, we'll take a look at another one. Now, this is one that frequently looks a little confusing because we just have a polynomial here times this rational expression. This is the same thing as multiplying the 4 minus 2x over 1. Okay, so anytime you have something that's multiplied to a rational expression, just treat it as if it was that rational expression over 1, and then do your multiplication. And so we end up with the top factors. We'll factor out the 2 here in the 4 minus 2x. So we have a 2 minus x here. And then we have this 2 plus x. And then in the denominator we have the 2 minus x. And then the 2 minus x here cancels, and we're left with just 2 times 2 plus x. But since we've eliminated this 2 minus x, we know that can't be 0. We can't divide by 0, so we have to retain that restriction, so x can't be 2. X is not equal to 2.
But when you factored out 2,
Yes. I factored out the 2 from this expression only. So this is 2 times 2 minus x.
yeah, oh, you didn't do it from the second.
Yeah, this other one you don't do because you have 2 plus x, and if you factor out this 2, you have to make this 1/2 x, and then you're not simplifying.
Okay. So I have to do it before.
Yeah.
Oh, I get it, yeah.
Okay, so here's one for you to try. We're multiplying, actually there's 2 of them here. We're multiplying those 2, so multiply those 2 out and simplify it, and be sure you keep track of your domain restrictions. How does this look? Okay, so that's the first step. Factored out the 6, just wrote everything together, and then cancel out everything that, so we have 4 times 6 divided by 3, so 6 divided by 3 is 2, 2 times 4 is 8, and so that takes care of all the coefficients. We still have an x that remains, so we have 8x, and then we cancel out the y's and the x minus y. And so here's the important part now, the domain restrictions. X can't be 0. Even though if it were 0 here, we get 8 times 0 is a perfectly good number, 0. We're dividing by 0 here if x equals 0. So we have to retain that. For the same reason we have to retain y doesn't equal 0. And x does not equal y, because then we would have this thing equal 0. Now it's kind of odd when you have an expression that's simply 8x, and you're saying your domain restriction is that y can't be 0. And presumably you've started with the y because it's part of the model that you're dealing with. You know, however you arrived at those expressions, whether it's some physical problem, an engineering problem, or an accounting problem, or something like that, you're going to have, you have 2 variables. You obviously defined them. And it turns out that this solution doesn't depend on y, but it only doesn't depend on y when y is not equal to 0. So if y equals 0, then there's no value to this. It's not part of the domain. So even though it may seem a little bit odd, it still has some meaning, and depending on the physical model or the physical reality that you're trying to model, it may be a meaningful result that that this expression is only 8x when y does not equal 0. Okay, how about the second one? Second one looks like we have 8 minus z, z plus 8, 8 plus z, and z minus 8. So when we write that, one of the things that we can do to make simplifying things easier is that when we have expressions that are not in the standard order because of a negative sign, factor out a -1 and get that expression in the regular order that we have polynomials, where we have them in highest degree first and that we factor out the negative coefficient. So now we can compare, and we have z plus 8 in both the numerator and the denominator, and z minus 8 in both the numerator and the denominator. So this one equals -1, but z can't be 8 or -8. So here again, this is an example where it may not make a lot of sense. If it equals -1, shouldn't it always equal -1? Well, it doesn't equal -1 when z is 8 or -8. Yes,
Why is there a negative and
because the negative 8 comes from when z is negative 8, we have a 0 here, and when z is 8, we have a 0 there.
In the, on top, why did you pull out a negative sign?
Make these comparable. It wouldn't necessarily occur to you, or maybe it would, that 8 minus z divided by z minus 8 is negative 1. It's to help match these things. So if we put them all in standard order, then we can see which ones are there and which ones aren't. If we have our result that said just negative, 8 minus z over z minus 8, that's not fully simplified. That is negative 1 except when z equals 8. Okay? And really that's all there is to multiplication. It's a matter of rewriting all the terms so it's one nice handy package, and you factor everything out, and then you cancel common factors to simplify it, and then list your domain restrictions based on what you've canceled out. So let's talk about dividing rational expressions now. Division works a lot like multiplication. If you recall the way you do this, let me write my little abstract theoretical formula up here first. If we have u divided by v, or u over v divided by w over z, so we have that division sign in here. And to me, that's one of my least favorite math symbols because it causes a lot of confusion. It's easier to write things as ratios than to write it like this. But anyway, when we have this and we have the division sign, the thing that we do is we change it into a multiplication by multiplying times the reciprocal of this second this second ratio here. And it's important that it's the second one because you can't take the reciprocal of the first because then we're going to get the reciprocal of the answer. All right? This is the same thing as if we're going to say 1 divided by 2 is the same thing as 1 times 1/2. Okay, so we take that 2 and we make it a 1/2. So, of course, we have to worry about, once we simplify it, we actually have u, w, and z can't be 0. If you look at this, if we have w equals 0, this is perfectly good expression, 0 over some non-zero number. That's 0, but then we're dividing by 0 with this overall operation. And so it turns out that the only thing that can be 0 in this whole expression here is that u can be 0. So 0 divided by any non-zero number is 0. And so that still holds here. We just can't have anything that we're using as a denominator or as a divisor can't be 0. Okay, so let's look at a quick example here. So if I have x over x minus 2 divided by x plus 1 over x plus 3, I just rewrite that as multiplication. So I take the reciprocal of this x plus 1 over x plus 3, and you see the x plus 3 is in the numerator now, x plus 1 is in the denominator. But even though I haven't canceled anything out, by making this a multiplication, I still have to state that x can't be negative 3 because I would be dividing by 0 with this first term. So this is implied here, that x can't be negative 3. But now that we've taken the reciprocal of it, it's not obvious at all. In fact, unless you state it, it perfectly could equal negative 3. You'd still get a nice 0 out of it. But here you have to make sure that we're calling out the domain restrictions of the things that we're changing from denominators into numerators. Okay, everybody follow here? So, yeah, the x is not equal to 2, x does not equal negative 1 is implied. So writing those is optional. I don't consider it wrong. If you do write them, you certainly don't have to. but what is required is this one. Yes?
So that's just following what you said up there, like, remember, like, you can stay, like, you doesn't have restrictions.
Right. U can be 0. So if we look at this here, let's say x equals 0, okay? So we'll have 0 divided by -2, and then this ratio is 1 divided by 3. And so when we do that, x divided by 2 divided by 1/3 is the same thing then as 0 times 3 still works. Okay, we get 0, a perfectly good 0. The only problem with 0 is that it can't be in the denominator. It can't be the value of the whole denominator, let me put it that way. Okay, go through a couple examples here. All right, so here I have x squared minus 1 over x plus 2 divided by x plus 1 over x plus 2. So my first step always is to rewrite this as multiplication. Now what I've done here is I've gone ahead and recognized that x squared minus 1 can be factored. So I'm writing those as two factors here, multiplying it by x plus 2 because I'm taking the reciprocal of the second expression here. Then I have x plus 2 times x minus 1 because that x plus 1 from the numerator now goes to the denominator. And so we have this. So we'll notice here that we have an x plus 1 that can cancel, we have an x plus 2 that can cancel, and so that leaves us with an x minus 1. And so we have to call out our domain restrictions. And the domain restrictions come from the fact that we have this x plus 2 can't be 0. And then down here we've also canceled the x plus 1, and so that can't be -1. And so we have those two domain restrictions and x minus 1. All right, another one, a little bit more complicated. I'm going to look at that first term and recognize I can factor out the 5 times x plus 1. And then here, I'm going to take the reciprocals and make this multiplication. And so that denominator, which is now put in the numerator here, factors to x minus 3 times x plus 1. And then this in the denominator, we can factor out the x and get x minus 3. So here's my entire unsimplified expression where it's just multiplication now. And so we compare terms, and we see we have the x minus 3 is common to both. And then we have the x plus 1 twice, so we can write that squared. It's not essential to do, but it's nice to do, to recognize that that's the same term. And so we call out the fact that x plus 1, because this comes from the denominator of this one here, we have x does not equal -1, and then we've canceled out the x minus 3, so we have two domain restrictions. So the trick here is to find all your domain restrictions. And so look in the fully factored expression that you're putting in the numerator that comes from the denominator of the divisor. Make sure you're including those as well. And especially if they don't cancel out, because then it's not entirely obvious from the expression even that it couldn't be 0. Okay, so I have two here, and I think what I'm going to do is I'm going to ask a couple people to come up to the board and write it out step by step. Okay, so Morgan Colmstead, this Morgan, will you do the first one? Okay, and Nathan, can you do the second one? Yeah. Okay, so whenever you're ready, come on up. If you're not getting it, ask your neighbor. Yes,
I'm kind of confused why say x cannot be negative 5.
because you've canceled out an x plus 5, and so this can't be 0. And so x plus 5 equals 0 means that x equals negative 5. It's this one that you're worried about. This one still is an implied one.
Oh.
Okay? Yes.
Why can't x be negative 5 in the first one?
Because she's 0.
Yeah, x can be,
Just 0.
yeah, just 0. Okay? Because
The side was-
negative 5 does nothing in here. Okay, there's no problem. It doesn't make anything 0. Okay, so my solution is 6 over x, and x cannot equal 0, but it's still implied. So you really don't even need to write either of these, but this one's still correct. And so we'll take the second one. You can see, take the reciprocal of that x squared minus 25 over x cubed. Cancel out common terms. And there's your required domain restrictions. Okay, so we're going to stop here. Monday we're going to talk about adding and subtracting polynomials, rational expressions.